To calibrate the pH sensor, first acquire 2 solutions of known pH. Here we're using a solution with a pH of 7. Enter the value of the pH and wait to click the Keep button until the voltage stabilizes. Repeat the process again with the second solution. Here we use a solution with a pH of 4. Again, wait until the voltage stabilizes and then hit the Keep button. Hit the OK button, and that's it. The pH sensor is calibrated. It is recommended that you rinse off the sensor with DI water before placing it back in its solution. Just be sure not to let the sensor dry out.
Next, rinse your reagent reservoir with a few milliliters of your prepared NaOH solution. Dump out the excess into a waste beaker. Add a little bit more of NaOH and open both valves to the vertical position to fill the tip of your reservoir. After, close both valves again. Use a clamp to attach the reservoir to a ring stand slightly above the drop counter, as shown in the video. Open the bottom valve and start to slowly open the top valve. Once a drop of NaOH is released every 2 seconds, close the bottom valve again. You will not adjust the top valve for the rest of the experiment. To calibrate the drop counter, tap Calibrate Now and then fully open the bottom valve so that the NaOH is being released into a 10 milliliter graduated cylinder. Make sure that every drop is being counted. Once the volume of NaOH in the graduated cylinder is between 9 and 10 milliliters, fully close the bottom valve. Enter the precise volume of NaOH and press OK. Place the pH sensor through the large hole in the drop counter and attach the micro stirrer, making sure that the rotating pedal doesn't hit the sensor when it rotates. Now place the pH sensor and the micro stirrer into your phosphoric acid. Your setup should look like this.
Hit the Run button and then open the dropper. Make sure that the drops are falling at an adequate speed. Here we had it at about 1 drop per second. If the speed at which the drops are falling is too fast, the drop counter might miss some drops, leading to a misrecording of the exact volume released. Additionally, the graph on the LabQuest will not have steep enough curves needed to make accurate calculations of the pKa.
If your NaOH is being added too quickly, this is what your graph might look like. This is what the graph of a good run would look like. To find the concentration of our phosphoric acid, we must first find how many moles of hydroxide we used. We started with 3.643 milliliters of NaOH, which we then converted to liters and multiplied by the molarity to get 3.97 times 10 to the negative 4 moles of NaOH. This is also the number of moles of hydroxide and phosphoric acid we have since we are using the first equivalence point. We then divide the number of moles of phosphoric acid by our total volume, which is the 40 milliliters of water plus the 1 milliliter of phosphoric acid that we added. We convert the volume into liters and we get a final concentration of 9.69 times 10 to the negative 3 moles per liter of phosphoric acid.